So graphing tangent and cotangent is actually going to be more about your algebra skills than about your graphing skills. Because a lot of things are the same. You're still looking at going up to 1 and down to -1. You still have a period. The period, however, is only going to be pi. Okay, so let's write that down. The period is only pi long instead of 2 pi. So you can still look at that stuff. The amplitude, however, is not really technically an amplitude because it does go above that, but it's still a point that we're going to be using. I'll show you that in a second. One of the interesting things about tangent, if you remember, sometimes when we found tangent, we would get things like 1 over 0. And if that happens, think about it, you can't divide by 0, right? So what's happening is when you get that, you can't have that x value. And so what's going to happen is you're going to have an asymptote. Just like before, when we couldn't divide by 0 and we had 0 on the bottom, we would have these asymptotes. And so with tangent, we get these asymptotes. Whoa, my pen flew. Okay, we get these asymptotes here. And then tangent's going to fit in between the asymptotes. And you'll notice on the asymptotes that the distance is pi. Okay, so that means that I'm going to fit one full cycle of tangent within 2 asymptotes. Okay, and then what tangent does is tangent's going to cross right in the middle. So you're going to figure out what is this point right in the middle of the 2 asymptotes. Okay, mine are already labeled, and we'll go through how to do this when they're not labeled like this, but this is the most basic tangent that we have. So our tangent goes right in the middle. And then what we're going to do is we're going to find halfway in between there. So I'm going to go halfway and halfway. And then what tangent does is tangent's going to go up. It's going to kind of look like an S. So I'm going to look at this halfway point, and I'm going to find that pretend amplitude. It's not really an amplitude because amplitude technically you go up to it and then you go back down. But this one we're actually going to go up to it and then we're going to keep on going. So I'm going to see where they meet, and that's where I'm going to put that point there. So I put my point here. On the right I go up, on the left I go down, so halfway through and down to the other asymptote. And so I keep on doing that, halfway, halfway, okay, halfway. And so you can kind of see where I've got this kind of graph looking thing that's looks like it's going up in a way. Okay, repeating over and over again. And then it kind of swoops up, if you think kind of almost like the side of a parabola or something, and then it reaches the asymptote over there, and then it swoops down and hugs the asymptote over there. So here we are graphing tangent. Okay, and we keep on graphing, and we keep on hugging the asymptote as we go. So you hug the asymptote on the right, going up, asymptote on the left, going down. And so I've just graphed a whole bunch of tangents, okay? Technically, this is one full cycle of tangent. So if we follow it from left to right, tangent goes up. Okay, and then it's going to hug and it's going to keep on going forever. So technically we didn't stop at the amplitude, we kept on going up. But this halfway point is still at that maximum point of 1. And then at -1 down here on the left. So this is what tangent looks like. It's just a cycle over and over again. But you'll notice that it's discontinuous because we have the asymptote cutting it in parts here. Okay. Now, the big part of all this is the asymptotes, figuring out where are the asymptotes. Typically, if tangent's not changed at all, if we just have the simple tangent equation, they are at the halves. So pi over 2, 3 pi over 2, 5 pi over 2, and so on are the negatives of that. Okay, so that's typically where they are. However, once we start putting in numbers here, things change on where amplitudes are. And so what we'll do is we'll use our amplitude formula. Now I'll give it to you like this. I usually typically use it like this though. So what's happening with amplitude is we're given this 2n plus 1 over 2 pi. This is how your book writes it. I prefer to take that pi and distribute it through. So now it's 2 pi n. So instead of 2n, I put the pi in there. And then instead of a 1, I put the pi in there. And now what we can do is we can pick n values. So if you remember before we were talking about in the circle, n stood for how many times around you're going. Well, that's the same thing here. N is standing for what amplitude you're talking about. So I typically go with n equals -1, n equals 0, and n equals 1. And then I plug them in, so we get 2 pi times -1 plus pi all over 2, and do that math. So we get -2 pi plus pi is -pi over 2. And then plug in 0, so we get 0 plus pi over 2. So I just keep on plugging it into this equation here. Okay, and then we get pi over 2. And then here we plug in 1, so then we get 2 pi times 1 is 2 pi plus pi over 2. That gives us 3 pi over 2. And you should recognize these because this is where they were before. We had pi over 2. Well, we had negative pi over 2, and 3 pi over 2. Okay? And so that's how we find our asymptotes. Now, it's going to be a little bit more complicated than that, but that's that in general. And then remember, just to remember, we've got tangent. It's going to go halfway in between is going to be where it crosses the axis. And then halfway between the axis crossing and the asymptote is where we go to our pretend amplitudes. And remember, tangent's going up. So then we can graph them going like this. Pretend amplitudes and going up. Okay, so let's do a little bit more work. Here's an example. Now we still want to leave our notes. We still want to talk about the period. Oh, sorry, amplitude. It's supposed to be called the vertical stretch. So we should probably call it what it's supposed to be called. Let me get rid of what I have written here. Okay, so instead of amplitude, let's call it the vertical stretch. So vertical stretch. Okay, normally, remember we're looking at this number in front of tangent. And so normally we'd say it's a 1, but here's a 3. So I'm going to call this vertical stretch of 3. Then we have the period. This time, instead of 2 pi divided by b, it's just going to be pi divided by b. And b is a number in front of x, so it's pi divided by 2. I'm not going to worry about with the quarters or anything like that. We're not going to worry about that. We should look at our phase shift. Our phase shift is pi over 2 to the left. And then our vertical shift is, if we look there, 1 down. Now, one nice thing about this is even though we took notes here, we don't actually have to worry about that because when we find our amplitude, all the work that we do for that will take care of that. So now let's talk about finding the amplitude. See, the amplitude comes from this formula, and the formula says you're going to take b times x plus c and set that equal to that 2 pi n plus pi over 2 thing that we talked about on the last page. Now the b times x plus c, that is just taking this part of the equation you were given. We're ignoring where you have your vertical shift. We're ignoring the vertical stretch or the amplitude. Is all we're taking is what's right after the tangent and before our shift. So all of this stuff, we're going to take that and we're going to put it right here. And it's set equal to here. So if I write that down, I've got 2 times x plus pi over 2 equals 2 pi n plus pi over 2. And then our job is, and I told you this is going to be mainly just working on your math and your algebra skills. What our job is to solve for x. I want to get x by itself. So the first thing I have to do is get rid of this 2 here. Now that 2, normally we divide by 2, but notice I got a fraction over here. That's going to be kind of messy. So instead of dividing by 2, I am going to multiply by 1/2. Makes it a lot better to work with. So I multiply by 1/2. Okay. Now, those cancel out, so now I have x plus pi over 2 equals, when I multiply by 1/2, now on bottom I'll have a 4, so I have 2 pi n plus pi all over 4. Then we're solving for x, so I'm going to subtract pi over 2. Okay, I need a common denominator so that I can subtract, so that one means I'm going to have 2 pi over 4, if you don't mind me just doing the 2 and the 4 on there. There's a lot of writing, so I'm trying to reduce that. Now this first part here, this is 2 pi n. Notice this doesn't have an n on it, so I can't combine it. So I'm still going to have a 2 pi n plus, then I look here, I have pi plus 2 pi. It's going to be 3 pi all over 4. And that's what x equals. So now I can figure out what my asymptotes are going to be. So once again, I'm going to plug in -1, 0, and 1. And sometimes it's better to plug in other numbers, but typically these work out pretty well. So if I plug in -1, I'm going to do this in my head instead of writing it down. When I plug in -1, that gives me -2 pi. Plus 3 pi gives me just pi over 4. So that's going to be one of my asymptotes. Then if we plug in 0, this cancels out. So then I just have 3 pi over 4. And then if I plug in 1, that gives me 2 pi plus 3 pi, that gives me 5 pi over 4. So what's going to happen is by doing these 3 asymptotes, I'm actually going to graph 2 cycles of tangent. One of them is going to be at pi over 4, one of the asymptotes. Then we have 3 pi over 4, so let me go pi over 4, 2 pi over 4, 3 pi over 4. You want to make sure that you space them out properly, so 3 pi over 4. And then 4 pi over 4 and 5 pi over 4 is my third one. Okay, now we can start graphing. So tangent is halfway in between, it crosses the axis. However, hold on, we have a vertical shift of 1 down. So now my axis is no longer on the x-axis, it's going to be down 1. So my tangent then is going to cross the axis right here. Okay. Then I have to look at the halfways in between. So I'm going to mark them on the axis up here. Halfways in between, remember tangent goes up, but remember now it's a vertical stretch of 3. So if I'm here at -1, then I have to go up 1, 2, 3. I have to go up to 2, and I have to go down to -4. So now for my halfway in between, I go up to 2 on the right, and I go down to -4 on the left. So this is really, really stretched out and skinny. Okay, whoop, that dot got a little bit high. And then I stretch it out and try and hug the asymptote. This is kind of a weird graph because it doesn't go very far. Okay, that was horrible, but you get the idea. Okay, so that's graphing tangent. This is pretty intense, especially this part right here. This is the part where you're going to have to work at your math skills to make sure you can do that, getting common denominator when you subtract, things like that. But that is in a nutshell how do you graph tangent.